Okay, as you all know, we have been working on parts of an expression. This expression has three terms. The first term has a coefficient and a variable. Now, on this foldable, I did not define coefficient, but the coefficient is the number that's in front of a variable. The variable is x. And on this foldable on the inside, we did evaluate the term 2x for when x is 4, and we got 8. And then we go over to the second term, and the second term has an exponent, which is 2. So we do 1/3 times 1/3. Remember that it is not 1/3 times 2, it is 1/3 times 1/3, and we got 1/9. In the order of operations, we would do parentheses first, but this set of parentheses does not have an operation in it. It only contains a value to separate that value from the exponent, and to also let you know that the entire value that contains a fraction is squared. So as far as the order of operations go, we will take care of the exponents first. And then the third term that we have on here is -6, which means that the term itself is -6 because we take the sign with the term. So this last term is a constant, and a constant is so constant it never changes. That's why it is constant. So this last term is -6, which means -6, and we leave it as is. These are all the parts of an expression, and this expression has three terms. Make sure you keep up with this, and let's go into the textbook questions. All right, so on this page, we are beginning with our unit in expressions. And if you look at the tracking sheet, you'll see that we need to cover uh, lessons 1, 2, 3, and 4 in chapter 5 so that we can write and evaluate numerical expressions using exponents in real world and mathematical situations, numerical expressions using the order of operations, write algebraic expressions given a verbal statement, and use the order of operations for algebraic expressions, and again the order of operations given fractions or decimals. So we want to get through these 4 lessons between today and tomorrow. Our goal is to get up to lesson 4. I do not think that we're going to get that far today, but that's our goal. So we're going to start with page 348, and it starts with powers and perfect squares. I'm going to give you an example of a perfect square, and then you're going to help me finish building them. So perfect squares are numbers like 100, because 1 times 1 is 1, and the square root of 1 is 1, so 1 is a perfect square. 2 times 2 is 4, and the square root of 4 is 2, so 4 is a perfect square. 3 times 3 is 9, and the square root of 9 is 3, so 9 is a perfect square. I only want you to write the numbers that are in purple. You don't have to write what's in pen. All right, now let's build this list. What's the next perfect square? What's the number?
16.
Okay. What's the next number?
5 times 25.
25.
36.
36.
49.
Okay.
64.
Look at y'all.
81. 100.
Okay.
121.
Mm-hmm. Okay, that's good. Those are the perfect squares. Now, you see that this square is two-dimensional. That's why it has a little exponent of 2, because that is length times width. A cube, however, is three-dimensional. It's length times width, and it also has a height. So, a perfect cube will be something like 4 times 4 times 4, which is 64. So let's see if we can name some perfect cubes up to 7. I'm going to help you, but you're going to help me also. So they go like this. 1 times 1 times 1 is 1. So 1 is a perfect cube because the cube root of 1 is 1. 2 times 2 times 2, because the cube root of 8 is 2. So 1 and 8 are perfect cubes.
The next one would be
27. So he has a calculator. Oh, what's the next one? 124? No. 64. 125.
So this is how many times it is. 216. 343.
I want to stop at 216 and 343. Now, you do not have to memorize those, but I do want you to be familiar with what they are because you will have to calculate them. These are your perfect squares and your perfect cubes. Okay, now, the next thing we're going to do is talk about products of exponents and powers as a product and finding the value of those. So we're going to look at the guidance for A through E. We're going to look at the guided problems for A through E. Now, so write each product using an exponent. We're not calculating these. You're only writing these using an exponent. So look at the examples above to see what you're supposed to do before you actually get to work on them. Square root symbol on the calculator. The difference between the square and the square root is, well, they don't have it on here, but this is the square root of 9. 9 squared is 9 times 9. That's two different things.
So what is the calculation for square root?
9 square root. Square root,
Are they dividing it by 3, 1/3, by its 1/3?
No, they're trying to find out what value times itself will give you that number.
What value?
Times itself will give you that number.
That's square root?
Yeah, that's this part right here. This is the square root of 9. What value times itself will give you that number? Squared is 9 times 9. So in other words, 9 times 9 will give you 81. So the square root of 9, but the square root of 9 is 3.
3.
The square root of 81 is 9.
3 times 1 gets you to the number.
Yes. One of them is what times what would give you to the number. The other one is the number times itself.
Wouldn't it be 3.5 times 3.5 or something? 3.5.
Somewhere in there.
3.5.
I have to teach you how to find that. That's well above your sixth grade standard. Okay, C. On problem C, we're writing the power as a product and then finding the value. So for C, you're writing it as 10 times 10 times 10 times 10 times, and the value is 100,000. For D, you're writing it as
2.1 times 2.1, which is 1.4, right? 1.4? Would you put the power? How would it go down?
no power because you're writing it in expanded form.
What? 2.1 is 2.1? What? No. It's 2.1 times 4.41. Yeah, it's 4.41.
4.41.
4.41.
4.41. Wait, I need to check that. 1/4 times 2. Would that just be 116? It's 5.2 times.
No, wait. It's just no, wait.
It's 35.2.
You're doing.
No. It's 1/4 times 1/4. Do not use a calculator for that. 1/16. All right, turn the page. One 16. You're welcome. Okay, so number 4. 2 times 2 times 2 times 2 times 2 is what? 32. Number 5, 1.4 times 1.4 is... Uh-oh, that's 2 different answers. 1/9600. All right, coal mines have shafts that can be as much as 7 to the 3rd feet deep. How deep is this? 343 feet deep. All right, where are we? How confident are you about powers and exponents? On target?
I'm on target. I'm on target. I'm in the middle.
I'm in the middle.
I need help.
Same, I'm built different.
All right.